Hi guys, welcome back to 6.2. Sorry, not sure what happened there, but my video cut out. So let's hope I can get to the end of this without my video cutting out again. We're talking about reference angles. We found the reference angle for 140 degrees to be 40 degrees because that's the difference between the terminal side of the angle and the x-axis. Remember, reference angles are always positive. So now things get a little trickier when we start working in the world of radians because our brains tend to think better in terms of degrees. So if that works for you to convert to degrees, you're welcome to, but just keep in mind if the question's asked in radians, you are expected to answer in radians. So make sure you convert back to radians. So you might see 7 pi over 6 and think, well, that's 7 times pi over 6, but pi over 6 is 30 degrees, so that's 210 degrees. So 210 degrees, well, we know this is 180 degrees right here. From here to here is 180. Well, to get to 7 pi over 6, which is 210 degrees, we're looking for this distance from the x-axis to that angle. It's only 30 degrees. But then you have to think, well, 30 degrees is pi over 6. So then the answer would be pi over 6. You cannot answer with degrees if the question asks for radians. Okay. Now converting 9 pi over 5 is a little bit trickier because it's not one of our multiples of 30 or 45. But you don't necessarily have to convert in order to go from radians, finding the reference angle for radians. Let's backpedal to this problem for a minute. We know that this is 0 and 180 degrees is pi radians. What I focus on is what we're looking at, what portions of the pi. We're looking at 1/6 or pi over 6. So I know pi must be 6 pi over 6. And I'm going to 7 pi over 6. So the x-axis is either 0 pi over 6. It's also 12 pi over 6. That would be 2 pi, but we're not way over there. This is the area that we're focusing on. So if pi is 6 pi over 6, our angle of interest is 7 pi over 6. Well, to get from 6 pi over 6 to 7 pi over 6, that's just one more pi over 6. So that was our answer. Let's see if we can think about that with pi over 5s. So I have 9 pi over 5. So instead of converting to degrees, which you're welcome to, you can multiply this by 180 over pi, plot the angle, see how far it is from the x-axis, and then convert it back to radians. Or I'm working with pi over 5s. So I know that this is 0, and I know this is pi, but pi over 5s, well, it would have to be 5 pi over 5 to give me pi. And this would have to be 10 pi over 5 to give me 2 pi. And I would keep going until I found the two that sandwich, 9 pi over 5. I know 9 pi over 5 is in between 5 pi over 5 and 10 pi over 5. So 9 pi over 5, well, if I divide this into fifths, 9 would be over here somewhere. So not exactly sure what it is, but I know that if I go 9 pi over 5 around, in order to get to 10 pi over 5, I just have to go one more pi over 5. If it was 8 pi over 5 instead, it would be 2 more pi over 5s to get to 10 pi over 5. So my answer is 1 pi over 5. We always eliminate the 1 because 1 times 1 is just pi. Right? Right, so reference angles are going to be very important. The next step is defining our trig functions on the unit circle. So by definition, now remember, you can define a function however you want to. So someone decided to look at the coordinates. So here's my unit circle. So this is the coordinate 0, 1. This is the point 1, 0. It says, let's look at an angle. And I'm just picking any angle. It doesn't matter that this happens to be 60 degrees. So if we take any angle on the unit circle, and we look at the point where it crosses the unit circle, where it intersects the unit circle. So this point of intersection right here, we know the radius is 1. All right. We define the sine of the angle to be the y coordinate of this point of intersection. We define the cosine of this angle to be the x coordinate of the point of intersection. And there's 6 trig functions based on just these 2 points. The tangent is the ratio of the y coordinate over the x coordinate. The cosecant is the reciprocal of the y coordinate. The secant, by definition, is the reciprocal of the x coordinate. And the cotangent is defined to be the ratio of the y coordinate to the x coordinate. Now, I'll never write out sine, cosine, tangent, all these full names again. We abbreviate the sine sin, so the sine of theta is the y coordinate. The cosine of theta is the x coordinate. The tangent of theta is equal to the y coordinate divided by the x coordinate. The cosecant, abbreviated CSC, is the reciprocal of the y coordinate. The secant is the reciprocal of the x coordinate. And the cotangent, abbreviated COT. All right, we don't call this the sin or the cos or the tan or the sec or the cot. So even though it's abbreviated SIN, we still call it the sine. COS, we still say the cosine. Tangent, cosecant, secant, and cotangent. All right, now remember, this is all based on the fact that we're assuming that we're looking on the unit circle. So if we go back to our unit circle, which you're going to become super de-duper comfortable with, right? Here's my unit circle, and here's where all our common angles intersect the unit circle. So that being said, I'm just going to pick 60 degrees to start with. Let's find all 6 trig functions for 60 degrees. So we're looking at this point right here. This is where 60 degrees crosses the unit circle. So the sine of 60 degrees, by definition, is the y coordinate where the terminal side of 60 degrees crosses the unit circle. So the sine of 60 degrees is the square root of 3 over 2. The cosine of 60 degrees is the x coordinate, 1 over 2. Now be careful here. The tangent is the y coordinate over the x coordinate, but we never leave fractions in fractions. So once I have these two, the other 4 just follow without looking up here. The tangent is always going to be this number over this number, so we always put the sine first and the cosine second. But notice, dividing by a fraction is the same as multiplying by its reciprocal, so the 2's are going to cancel, and the tangent's just going to be the square root of 3. So if you take the numerator of the sine and the numerator of the cosine and just take that ratio, it'll always give you the tangent. The cosecant is just the reciprocal of the sine, so we can just take the sine and flip it over. But remember, we never leave radicals in the denominator, so we're going to rationalize this by multiplying the top and the bottom by the square root of 3. So the cosecant of 60 degrees is 2 square root of 3 over 3. The secant is just 2 over 1, but we always write just 2, because 2 divided by 1 is just 2. And the cotangent is, well, it's the reciprocal of this. It'd be 1 over the square root of 3, and then we rationalize it, and we get the square root of 3 over 3. There we go. There are our 6 trig functions. Now you are expected to know the exact values or be able to find the exact values of trig functions. If you go in your calculator and you make sure you're in degree mode, if you go under mode in your calculator, you make sure you're in degree mode. And then if you type in, let's see if we do the cosine of 60 degrees, we hit cosine and we hit 60, it's going to tell me it's 0.5. That's 1/2. But if you take the sine of 60 degrees and you get 0.866, that's an approximation. The exact value of the sine of 60 degrees is the square root of 3 over 2. So, and if you notice, if I find the square root of 3 and divide it by 2, I get 0.866. But you want to know that it's the square root of 3 over 2. So you want to be able to do this without your calculator, okay? All right, let's find all 6 trig functions for 5 pi over 4. So 5 pi over 4, well, this is 4 pi over 4, so 5 pi over 4 is right here. So we're looking at 5 pi over 4, and these is our coordinates of interest. So the sine of 5 pi over 4 is the y coordinate, negative square root of 2 over 2. The cosine has the same value as the sine because the x and y coordinate are the same for all multiples of 45 degrees because they cut through the diagonal. The tangent is, well, it's this numerator over this numerator. It's negative square root of 2 over negative square root of 2 is just positive 1. So watch your signs. This cosecant is the reciprocal of this. So 2 over negative square root of 2. We rationalize that. Multiply the top and the bottom by the square root of 2. And you get 2 square root of 2 over negative 2, which is negative square root of 2. So the cosecant of 5 pi over 4 is negative square root of 2. Well, the secant is the same as the cosine, which is the reciprocal of the cosine, which is the same as the sine. So we already know that that's negative square root of 2. And then the cotangent is just, we flip those over, it's also just 1. Not too terrible. Find all 6 trig functions for pi over 2. All right, now you have to be careful here because pi over 2 falls on an axis. That is, let's change to purple for pi over 2. Pi over 2, we're going to use this point. So the sine is the y coordinate, cosine is the x coordinate, the tangent is the y over the x. But that's undefined. There is no tangent for pi over 2. If you try to take the tangent of pi over 2, I'm in degree mode. Remember, pi over 2 is 90 degrees. If I take the tangent of 90 degrees, it says error in the domain. There is no output for the tangent of 90 degrees. As a matter of fact, there's no output for any angle for the tangent of any angles whose terminal side lands on the y-axis. The cosecant is just going to be 1 over the y-coordinate. The secant is going to be 1 over the x-coordinate, undefined. So the secant is also undefined at pi over 2. The cotangent, be careful because remember the cotangent, the tangent is y over x. The cotangent is x over y. It's 0 over 1, and 0 over 1 is 0. So we want to know all the basic trig functions of all our angles. So maybe this chart you'll find a little helpful. We look at an angle whose terminal side lands on the positive x-axis. So any angle, 0, 360, negative 720. If an angle's initial side and terminal side land on the positive x-axis, its sine is always 0, its cosine is always 1, its tangent is 0 because it's 0 over 1, its cosecant is 1 over 0, it's undefined, the secant is 1 over 1, and the cotangent is 1 over 0, it's undefined. So any angle whose terminal side lands on the positive x-axis, these are the values of the 6 trig functions. If an angle's terminal side lands on the positive y-axis, well, the sine was 0 here, and now because that was the x-coordinate, right, the y-coordinate, we're switching. This now becomes 0, 1. So this is going to become 1. The sine is that. The cosine is 0. The tangent is undefined because it's 1 over 0. Undefined. The cosecant becomes 1. The secant becomes undefined because it's 1 over the x-coordinate. And the cotangent is x over y, so it's 0 over 1. It's 0. Any angle whose terminal side lands on the negative x-axis, well, the coordinates at this point are negative 1, 0. Sine is 0, cosine is negative 1. Tangent is 0 over negative 1, 0. The cosecant is undefined whenever the sine is 0. The secant is just going to be the reciprocal of that. And the cotangent is undefined whenever the tangent is 0. Undefined. And then any angle whose terminal side lands on the negative y-axis, the sine is, well, the coordinates at this point are 0, negative 1. So the sine is the y-coordinate, the cosine is the x-coordinate. The tangent is y over x, it's undefined. The secant's the reciprocal of the sine. The cosecant, if that's what I said, is the reciprocal of the sine. The secant's the reciprocal of the cosine. So the secant's undefined when the cosine is 0. And the tangent is undefined, but the cotangent is x over y is 0. All right, what I tend to remember is that the sine here is 0. The sine goes from 0 to 1, back to 0, negative 1. And then it goes 0, 1, 0, negative 1. The cosine, anytime an angle lands on an axis, its sine and cosine are either 0 or 1. When the sine is 0, the cosine is either 1 or negative 1. And when the sine is 1 or negative 1, the cosine is 0. So the cosine starts at 1, switches to 0, goes to -1, and then goes back to 0, and then goes back to 1. So if you can remember the sine and the cosine and how they behave, then you can find the other 4 trig functions. A couple other important tidbits of information. All right. If an angle's terminal side lands in quadrant 1, well, in quadrant 1, both your x and y coordinates are positive. So in quadrant 1, the sine, the cosine, and the tangent are all positive. So if the sine is positive, then the cosecant is positive. If the cosine is positive, then the secant is positive because they're just reciprocals. And so all 6 trig functions are positive in the first quadrant. If your angle and your terminal side lands in the second quadrant, well, the sine is going to be positive because the sine depends on the y-coordinate, and the y-coordinate is positive in the second quadrant. But the cosine is negative. For any angle whose terminal side lands in the second quadrant, its cosine is going to be negative because it depends on the x-coordinate. The tangent is the y-coordinate over the x-coordinate, so it's a positive number over a negative number. So from this, you can deduce the other 3. The cosecant will be positive, the secant will be negative, and the cotangent will be negative. If you're an angle and your terminal side lands in the third quadrant, both your x and y coordinates are negative. So the sine, because it's based on y, is negative, and the cosine is based on x, are both negative. But be careful because the tangent is the y coordinate over the x coordinate, and a negative over a negative is a positive. So then our other 3 reciprocal trig functions follow. The cosecant is negative, the secant is negative, and the cotangent would be positive. And then lastly, if your terminal side lands in the fourth quadrant, your x-coordinate is positive, your y-coordinate is negative, so your sine is going to be negative, but your cosine will be positive in the fourth quadrant. And your tangent is a negative over a positive, so it will be negative. Right. So here your cosecant will be negative, your secant will be positive, and your cotangent will be negative. And I have a corny little acronym. If you can remember A, S, T, C, kind of like PEMDAS, it's one of those things. So A means all, S stands for students. Take calculus. So just a corny little acronym to help you remember of the main, we call these the main trig functions, and then these are the reciprocal trig functions. Of the main trig functions, they're all positive in the first quadrant. So if we go around counterclockwise, A, S, T, C, just the sine is positive in the second quadrant, and then the other 3 follow. In the third quadrant, for T, for all students take calculus, T for tangent, just the tangent is positive. Right, all of them were positive. And of the 3 major trig functions in the fourth quadrant, just the cosine is positive. So all 3 major trig functions are positive in the first quadrant, just the sine is positive of the first 3, just the tangent is positive in this third quadrant, and just the cosine is positive in the fourth quadrant. All right, just a little side note. All angles have the same 6 trig values, maybe with a plus or minus added as their reference angle. So if we find all 6 trigonometric functions for pi over 6, for 7 pi over 6, we could just look at pi over 6. So if we know everything about pi over 6, then we know everything about 7 pi over 6. So let's look at 7 pi over 6 and pi over 6. Notice they have the same x and y coordinates. These are just both negative, and those are positive. So we have to remember that 7 pi over 6, if we look at it, 7 pi over 6 falls in the third quadrant. So I know this is going to be negative, negative, positive, negative, negative, positive. So keep that in mind. So you can either use, if you remembered what's going on with your first 3 angles, we can just use the values from pi over 6, or we can use our unit circle right now and say that the sine of 7 pi over 6, right, we're now down to, I'm running out of colors, we're now looking at this guy, right? The sine of 7 pi over 6 is the y-coordinate, -1/2. The cosine of 7 pi over 6 is -square root of 3 over 2. The tangent is going to be that y coordinate over that one. A negative over a negative is a positive. 1 over the square root of 3. We rationalize that, the square root of 3 over 3. The cosecant is the reciprocal of the sine. It's 2 over 1, so it's negative 2 because the cosecant is negative. 2 over the square root of 3, negative. We're going to rationalize it, negative 2 square root of 3 over 3. Now here the cotangent, well, we could flip this, but it's a lot easier to flip the tangent, then we don't have to rationalize it. Square root of 3 over 1, which is the square root of 3. If we flipped the square root of 3 over 3 and rationalized it, we'd still get square root of 3. So there's your 6 trig functions for 7 pi over 6. So you might say, oh, why did you bother even saying this about the reference angle? Well, let's look at 480 degrees. 480 degrees is not on my circle at all. But if I go 360 degrees, and I have to go how much more? 120 degrees. So we can either use 20 degrees or 60 degrees. Actually, I'm going to go with 120. So 480 degrees is coterminal. I should have said this instead. Let's add this. Coterminal with 120 degrees. And coterminal angles have the same 6 trig functions because they land in the same exact spot. So we're going to look at 120 degrees, and we're going to conclude that the sine of 480 degrees is the square root of 3 over 2. And you can check in your calculator. Cosine of 480 degrees is negative 1/2. Although remember, I don't want the decimal equivalent. 0.866 does not work. The tangent of 480 degrees is that numerator over that one, negative square root of 3. The cosecant of 480 degrees, 2 over the square root of 3, which is 2 square root of 3 over 3. The secant's negative 2. This is going to be negative 1 over the square root of 3. We just take the reciprocal of the tangent, so the cotangent will be negative square root of 3 over 3. All right, let's just take this up a slight notch for our last problem. So we were working with nice angles so far. All these angles on the unit circle, we can just pop in and look at the unit circle and make conclusions. All right, well, what if I said we have an angle, and I know its terminal side, I know that the sine of the angle is 2/3. I want you to find the remaining values of the trig functions. So what we do know, if the sine, it's in quadrant 2, the y coordinate, so if it's in quadrant 2, it lands, here's my unit circle. This is right here is, right here is 2/3, which is 0.666. So this is what my angle looks like. Now notice it doesn't ask for the angle. I don't want the angle. I just want to know the 6 trig functions. I know the y coordinate of that point is 2/3 because I know the sine of the angle is 2/3. So remember, this is 1, right? What I need to know is now what is the x coordinate. So we don't know the x coordinate. I know it's between negative 1/2 and negative 1. I know this is 2/3. So I know that x squared plus 2/3 squared is going to equal 1 squared by Pythagorean's theorem. So x squared plus 4/9 equals 1. So x is going to equal 5/9, the square root, which is the square root of 5 over 3. But now be careful, x, we are in the second quadrant, so x is negative, because when we take the square root of something squared, it's positive or negative. So using Pythagorean's theorem, we find that the x coordinate of this point, I know the sine is 2/3, the x coordinate must be square root of 5 over 3. So now again, it doesn't ask me what the angle is, it just asks for all the trig functions. So now that we have our picture drawn, we have the point that this angle intersects the unit circle. We know that the sine of the angle is 2/3. We just found the x coordinate using Pythagorean's theorem. It's negative square root of 5 over 3. The tangent of the angle, notice the denominators are the same, so when I put y over x, the denominators cancel, and we get 2 over the square root of 5, and it's going to be negative. We're going to rationalize this. So negative 2 square root of 5 over 5. I always go down in the second column. I'm going to do the cosecant of the angle is just going to flip the sign. It's going to be 3/2. The secant of the angle is the reciprocal of the cosine, negative 3 over the square root of 5. which is -3 square root of 5 over 5. And then the cotangent of the angle. Well, I could take the reciprocal of that one or this one. This one's easier, then we don't have to rationalize it. Negative square root of 5 over 2. All right, so I suggest for now that you print off the unit circle. Memorize at least the points in the first quadrant. Right, and then that will help you find all the points in the rest of the circle, okay? All right, have fun with this. See ya.